Okay, so what we're going to be looking at today is still looking at compound, instead of compound angular drilling, we're going to look at a compound angular surface. So what we're going to be looking at is, let's take our block, and what we're going to be doing with it today is we're going to be taking a corner off our block. So we're going to be milling that corner off so that the block now looks like that. That edge doesn't magically disappear, so there. So now what we have to do is we have to rotate this block so that it's sitting, so that this edge, if you're looking at the table of the mill from above, here's your mill, so that that edge in blue is sitting this way. So the block's sitting like that, right? And then you've got to know what angle to tilt the head of the mill, so that the head of the mill, if you're looking at it from the front side, so the head of the mill now is angled into that. Does that make sense? So we have an angle of rotation here. Our angle of rotation is going to be the angle that this takes on. And that would be basically this angle here. It would be R. It's also, if you think of it as, this corner still being here, that would be this angle right here, R. Your angle of rotation.
It's not the one at the bottom?
Nope, it's not at bottom anymore. It's from the top surface. It's the angle between this edge here and this edge here. It's how far it has to rotate. Actually, it can be on either side, but we're using that edge. The tilt is a little more difficult. The tilt comes in here. I'm looking at this at a right angle to that edge for our rotation. It's this angle in here. That's my angle of tilt. That's how far we have to go from this being flat now to this being flat. That in there. But it's measured from a right angle from this edge here.
You're basically tilting the triangle on the end.
Yeah. We're getting this triangle here laying flat. Yeah. That's exactly what we're doing. So let's take a look. So I'm going to take these out again. So what we're doing, what we're going to be given here is we're going to look at this from this end. And from this end, we're going to be told this angle here is whatever. We're going to call it angle B. And we're going to be told that it is 24 degrees right now. Then from this end, we're going to look at it. And we're going to be given an angle there. I'm going to call that angle A. And let's say that that angle is 18 degrees. Now, what do we know? Well, we know that this depth here and this depth here are the same, don't we? We don't know what they are. But just like with our boring from yesterday, we don't have to know. We can make it whatever we want it to be. I'm going to make it 10 millimeters. Does that make sense? So now this is a right angle, right triangle. This side here is going to be found using an inverse tangent. Now again, we don't know what the actual lengths are, but it's the ratio of lengths. So we can pick one length to be whatever we want to, and the other ones fill in off of that length. So that's going to be an inverse tangent, or so not an inverse tangent, it's a tangent of 24 degrees equals 10 over, I'm going to call that xb. That's the x coordinate from b. So I've got to do it like this. 1 times 10 divided by tangent of 24. So 22.46 millimeters. We'll do the same thing over here now. Tangent of 18 degrees equals 10 over XA. So 1 times 10 is 10, divided by the tangent of 18 degrees, 30.78 millimeters there. So what that means is if I look up here, if I draw, I'm going to draw a little brighter color, I'll put it in red. If I draw this back in here, this side right here is 22.46, and this side right here is 30.78, which means this angle right here is going to be what? Well, this is a right angle in the corner, correct? So since that's a right angle in the corner, this is going to be the inverse tangent of 22.46 over 30.78, opposite over adjacent. Giving us 36.12 degrees. That's our angle of rotation. So R is 36.12 degrees. Now to find T, we've got to come back here at a right angle. And then what we're finding is this triangle here. If I look at that triangle there, it looks something like this. This is my angle T. I know this side here because that's the side I picked to be 10 millimeters. So I know that's 10 millimeters. Does that make sense? Because that's my depth. This side right here, my depth that I chose here and here. So what I need to find is this top side here, and that's this right across here. What I can do for that is I can actually look at this triangle right here. Now that I know that that's 36.12 degrees. So I can look at this triangle on top. So that triangle on top there, this is 36.12 degrees. This is just this side here with 30.78. And I need this side right here. So I'll call that Y for now. So this is going to be a sine, because I have the opposite and adjacent. Sine of 36.12 degrees equals Y over 30.78. So it's going to be 30.78 times the sine of 36.12. Give me 18.14. So this is 18.14 millimeters, which means this here is 18.14 millimeters. So now T is going to be simply an inverse tangent of the opposite side of 10 millimeters over the adjacent side of 18.14 millimeters. Here is 28.87 degrees. So their tilt, 28.87 degrees. What do you think? Good stuff? The tough part here is envisioning the triangles. Because first you've got to envision this triangle, which is on this side. Then you got to envision this triangle, which is on this side, knowing that they both match up on this edge. So these are the same. Then you've got to envision the triangle here that's up top, knowing that those two sides come from these two sides. Then you've got to try to envision this triangle that's sitting vertically now in the middle. I mean, so you got triangles going every which direction, but they all share sides. And that's what you got to be able to see in these problems. You've got to see the triangles in the different planes, but you also have to see where they share sides and what sides have to be equal and translate from one to the next. Get confused, Richard? The visualization getting you? You got her? Okay. Let's see, do I have one of these? Yes, I do. Like for this one, the hardest part is envisioning T. I mean, you're looking at this triangle like right here, and T is this angle right in, get this turn, see, actually, is this angle right in here, right there. So it's hard. And of course, this height is the height that we used on this triangle and this triangle. So that height still goes into T, but you got to find that top length for T. Well, again, that's not horribly different from what we've been doing. So I'll turn you loose in the new packet, page 410 through 411. 1 through 14, if you just want to do the odds, that would be wonderful.